guys, so we have been talking a lot about polygons, trying to identify whether they're regular, irregular, concave, convex, all that good stuff, right? We've talked about interior angles, exterior angles. So in section 6.2, we are going to start talking about the properties of parallelograms, which means we are going to be talking about all these different special quadrilaterals, okay? So bear with me, it's going to be a little vocab heavy in the beginning, and then we'll dive into some examples. So a special quadrilateral, okay, first we need to figure out what a quadrilateral is. So any polygon with 4 sides is considered a quadrilateral. All right, we've been working on identifying whether a figure is or is not a polygon, so identifying a quadrilateral should be pretty easy. Okay, a quadrilateral with 2 pairs of parallel sides is a parallelogram. All right, so it has 2 pairs of parallel sides, not just one, all right? It's got to be both pairs. The symbol for parallelogram is actually just a little parallelogram, which is nice and easy, okay? So let's talk about this then. Let's talk about some new theorems that we're going to have. So if a quadrilateral is a parallelogram, then its opposite sides are congruent. All right, so we are starting with this picture here. We've got both pairs of opposite sides are parallel. So AB is parallel to CD. Remember, that's what our arrows mean. Excuse me. Sorry, I couldn't think of the word arrow for a second. And then we've got 2 sets of arrows on BC and 2 sets of arrows on AD. That means that BC and AD are both parallel to each other. So we know for sure that this is a parallelogram, right? It's a four-sided figure, 4-sided polygon, and both pairs of opposite sides are parallel, which means, according to this first theorem, that segment AB is congruent to segment CD, right? That's one pair of opposite sides. And the other opposite sides are congruent as well. So that would mean BC and AD. So segment BC is congruent to segment AD. Okay, so that's one, right? If parallelogram, then opposite sides congruent. Then we've also got if a quadrilateral is a parallelogram. I think I just spelled that wrong. I'm missing an L. Parallelogram. Wow, sorry guys, I'm still waking up a little bit. My bad. If a quadrilateral is a parallelogram, then opposite angles are congruent. Okay, so again, we're given this same figure that we were given in the first one. We've got these sides marked parallel and these 2 sides marked parallel. So that's a good thing. That means then that our opposite angles are congruent. So for example, angle B is congruent to angle D. That's right here. Angle B and angle D. And it also means that angle A is congruent to angle C. So that would mean right here and right here. Okay. The third one, if a quadrilateral is a parallelogram, then its consecutive angles, so not talking about opposite anymore, now we're doing consecutive, its consecutive angles are supplementary. Okay, so let's think about what that means for a second. We have to remember that supplementary means that they add to 180 degrees. Okay. And consecutive means that they are next to each other. So let's think about what this would mean. Looking at our figure, we've got a four-sided quadrilateral. Opposite sides are parallel, means we do have a parallelogram. So our conclusion is that consecutive angles are supplementary. So for example, the measure of angle A plus the one next to it, so let's go measure of angle B, has to be 180 degrees. They have to be supplementary. It also means that the measure of angle B plus the one next to it, angle C, is 180. And the measure of angle C plus the next one, measure of angle D, equals 180 degrees. And the last one too, measure of angle D plus measure of angle A has to be 180 degrees. And this should definitely make sense to you because we've talked a lot about parallel lines. And if I were to extend these, let's start with AB and CD. If I were to extend those lines a little bit and make them so that they're clearly parallel lines, and I used AD as a transversal, then angle A and angle D are same side interior angles, which means they're supplementary. That's something from all the way back in chapter 3 that we learned. So now we're just applying it to this new figure. Now we're not talking about these crazy lines and a transversal and all that. Now we're just saying, hey, parallelogram, consecutive angles are supplementary. It's the same idea though. Okay, it comes from those thoughts in chapter 3. Okay, one more theorem we have to talk about. If a quadrilateral is a parallelogram, hey, look, I spelled it right this time, guys. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, this is a really important theorem. They're all pretty important, but this one is one that we use not quite as often, so it's a little bit harder to remember, but it's just as important. Okay, so we have a parallelogram, and we're saying that the diagonals bisect each other. Remember that bisect means that it cuts in half. Okay, diagonals go from one vertex to a non-consecutive vertex, which means AC is a diagonal. And it also means that BD is the other diagonal. Okay, so they are bisecting each other. That means then that AZ is congruent to ZC. AZ is congruent to ZC. And it means that BZ is congruent to ZD. So make sure you've marked your diagram also. Notice how when I made those congruent marks there, AZ and ZC have one tick mark, BZ and ZD have two. I don't care which tick marks you use, but they do need to be different from each other. This theorem is not telling you that all four of those segments are congruent. They're telling you that the two diagonals bisect each other. Okay, they do not necessarily have to be the same. Okay, in fact, most of the time in a strict parallelogram, they're not. Okay, we'll get into different types later. So for now, please make sure your diagram is marked accordingly. Okay? All right, let's do some properties. Let's do some problems, applying these properties. Okay, so there's our learning target. I can apply properties of parallelograms to solve problems. So let's take a look at the first one. It says that the figure is definitely a parallelogram, right? The directions even tell us that, so that's good. It says find the values of x and y and justify your answers. So taking a look at this, we know that this figure is a parallelogram. So I'm going to go ahead and just mark that these two segments are parallel to each other. and these two segments are parallel to each other, because that's what I'm told, right? And we have to think about those properties that we just went through. So one of the properties is that opposite angles are congruent. Okay, so let's use that. We know that angle Y then is 125 degrees. Okay, so Y is 125. And if we think about X, well, the 125 and the X, those are consecutive, right? Consecutive angles. And in a parallelogram, they're supplementary, which means they have to add to 180. So if I do 180 minus 125, I get 55 degrees, which means that X is 55. Okay, and technically if we wanted to, actually, we could have used that then, once we got that, to say that X and Y are also consecutive and supplementary. So we could have done 180 minus 55. Still get to the 125, right? So for our justification, we're actually going to write both. We're going to do if parallelogram, then opposite angles congruent. Okay, that's how we got Y. And then to get X, we used the fact that we have consecutive angles, right? So if parallelogram, because that's what we started with, then consecutive angles are sup. Okay, so because we found two different values and we actually used two different properties, I do want you to include both of those justifications. Notice I used shortcuts. I used the symbol for parallelogram and the symbol for angles and congruent. I'm totally fine with that. Okay, if you want to write them completely out, you can. I would use the shortcuts because it's easier. So, but keep that in mind. If you have two different justifications, you do need to give me both of them. Taking a look at number 2, we've got this picture here. We do know for sure that it's a parallelogram. So I'm going to go ahead and mark my parallel lines just to remind myself that it is a parallelogram. And taking a look at this one, it looks to me like we're looking at the diagonals, which means that I have these two segments are congruent to each other, and I have these two segments are congruent to each other. Because if I have a parallelogram, then the diagonals bisect each other. So I'm actually going to write my justification first so that I don't forget. So if parallelogram, then diagonals bisect each other. Okay, and so what that means then is that those pieces have to be congruent to each other. So if I take a look here first, it means that 14 has to equal 3x minus 1. All right, that's my diagonals that have the 1 tick mark, the pieces of my diagonals that have the 1 tick mark. So I can add 1 to get 15, and then divide by 3, and I get x equals 5. All right, that's my first variable. And then to get y, I can do the same thing. I've got 2 tick marks here and here, because this diagonal is being bisected, which means that 16 equals 4y plus 4. And then we can solve for y. So subtract 4 and we get 12 equals 4y. Divide by 4 and we get y equals 3. Okay. Marking your diagram is going to be your best friend, guys, I promise. Okay? You want to mark what you see so that you can then use those properties. All right, number 3, I'm actually going to have you guys do on your own. So I'm going to circle that and tell you to finish it up on your own for homework. Make sure that you not only solve for x and y, but that you justify your answer. Think about those properties that we've been talking about. Okay, flip back a page if you need to. But we're going to go ahead and move on. So, question number 4. Okay, the following figure is a parallelogram. Find each measure and justify your answer. So we need to find angle B first. So if we take a look, we know that angle B is this 6y plus 5. Okay, this 5x plus 19, that's a segment. That's not going to help me at all. So I need to look down here where I have another angle. I have angle A. Okay, Well, those two angles, they're not across from each other, right? They're right next to each other, which means that they're consecutive. And consecutive angles are going to be supplementary. So let's write our justification first. So if parallelogram, then consecutive angles are supplementary. Okay, having that justification is what allows me to write my equation. So 6y plus 5 plus 10y minus 1 has to equal 180 degrees. Because they're consecutive, well, actually, first of all, because it's a parallelogram, and these are consecutive angles, they're going to be supplementary. Okay? Then I can solve for y. Now it's nice and easy. So 16y plus 4 equals 180. I did that by just combining some like terms. Okay? Then I get 16y equals 176. Subtract the 4 over, right? And then divide by 16, and I end up getting y equals 11. Okay? But it didn't ask me for y up here, did it? It asked me for the measure of angle B, which means I have to plug that in and find it. So, measure of angle B equals 6y plus 5, and I'm going to plug in that 11 for y. So I get that the measure of angle B is equal to 71 degrees. Okay, all of that work came because of this justification. If parallelogram, then consecutive angles are sup. That's why I could add my two angles together to 180, and then I just solve for y and plug it back in. Cool? Now I need to look at AD. So now it's asking me to find AD. Well, AD is right here. This is that 7x. Okay, and I have this 5x plus 19. So we have to think about the properties of parallelograms. And we know that opposite sides are going to be congruent. So I can put tick marks there. Okay, well, congruent means that they're the same. That means I can say 5x plus 19 equals 7x. And I know that because if I have a parallelogram, then opposite sides are congruent. Otherwise, I can't just pick two things and set them equal, right? I don't get to just set things equal and make up equations. I have to have a justification for them, okay? But now we can just solve for x. So 19 equals 2x, divide by 2, and we get x equals 9.5. And it asked for the measure of AD, or the length of AD, excuse me, not the measure. The length of AD, which we know is 7x. So 7 times 9.5, we get that AD is 66.5. Okay? Make sure that you have all your work shown there and that you have your justification. Okay? Without the justification, your work means nothing. All right? And we've got question 5 here. All right. We are given AE is 3x minus 7. So I'm going to put that in here, 3x minus 7. And we know that BE is x plus 1. Okay. And BD is that whole diagonal. So BD is 4x minus 4. So I'm just going to box that. I can't really draw it in here necessarily because BD is the whole thing. Okay, if I wanted to, I guess what I could do is draw a big bracket and then say that that whole thing is 4x minus 4. Okay. So I'm going to let that clear up for a second. There we go. Now you guys can see. So we have to think about what properties are going to be helpful here. Well, since I'm given BE and BD and AE, those are all either a full diagonal or parts of diagonals. So we're going to have to use that fact. The fact that diagonals have to be bisecting each other because we have a parallelogram, which means that segment BE is congruent to segment ED. That means that ED has to be x plus 1. Okay? And technically, if I wanted to, I could say then that EC has to be 3x minus 7. It doesn't really help me right now, but it might help me later. So my first justification, I was able to say that ED equals x plus 1. So I'm going to write that up here. And the reason I was able to write that is because if I have a parallelogram, then diagonals bisect each other. Right? So because I have BE, I know that ED has to be the same. Well, now I can go back to some of my stuff all the way back from chapter 1. I know that BE plus ED has to equal BD, right? I've got a small part, and I've got the whole. So now I can set up an equation. X plus 1 plus x plus 1 equals 4x minus 4. And now I can solve for x. Okay? So 2x plus 2 equals 4x minus 4. And I can solve to get x equals 3. Okay? And I can actually just plug that right back into AE, because that's what it was asking for over here. AE. So that's going to be 3 times 3 minus 7, which means that AE is going to be 2. Okay. And then AE is only a portion of this diagonal, but I do know that the other one is congruent to it, which means the other piece is also going to be 2. And so AC is a total length of 4. Okay, we ended up using the same properties here, so we actually don't need this second justification. Okay, we were able to just double this for the same reason. Diagonals bisect each other. Okay, I know this video was a little bit longer. Hopefully you were able to follow along with it. Do not forget to finish up question 3 before you come into class. I will see you guys later. Bye!